Okay, we're on graphing rational functions. Okay, there are a couple things you need to know about graphing rational functions. I just need to make sure you're good on a couple things. Do you know what an asymptote is? It's an actual math word. Let me just asymptote. In words, still a lot of chit-chatting. Okay, still a lot of chit-chat. So an asymptote is a vertical or horizontal line that a graph approaches, but never touches. Kind of like the ladies in Travis. Woo! Oh, you can't read either. Your problems are just stacking up. Okay.
Can you read the bottom half?
Yeah, vertical or horizontal line that a graph approaches but never touches.
Great.
Asymptotes are dashed lines usually.
Great.
Rational functions have a lot of, or have asymptotes in them. I'll show you how to find them. It's really pretty straightforward. So this graph right here has asymptotes. So this one is vertical, right?
Wait, are we supposed to start graphing these things?
We are going to today. Okay.
That's food for thought.
What?
That's fun.
Oh, I have all day. And gals, mostly gals. I know. Thank you.
He has no problem to drive a Dodge.
You drive a Chevy, oh, what's the difference? Okay, can we?
Anything that runs and drives is good enough.
Now it's mostly guys.
I will prove it by
My preferred brand is Chevy, but I have never owned a Chevy. I've only owned Ford, Dodge.
Alright, stop.
But I would rather own a Chevy.
Are we ready? Okay. So the purple is the graph. It never touches the dashed blue lines. Those are called asymptotes. So this is a vertical. I spelled that. Asymptote. And the equation of that vertical line is x equals 2 because it's at 1, 2 on the x-axis. This would be a horizontal asymptote. What's the equation of that line? Yep. They're really easy to identify in a rational function. So are we good on those two definitions? Or that definition, really, what it is. Okay. Yeah, that's a rational function.
What is these graphs going to be good for? Just good. Besides, like, if you're going through a career with massive amounts of math.
You want to think
everyday thing that you
and
see.
problem. Oh. Have you ever seen this in real life? Probably nothing.
Like, if you say devices, but you don't go to them. Like satellite needs grab those and grab. But you don't think that the satellite needs grab those and be a satellite.
The programming might use it. I don't know. I'd have to look. This is more of a skill that builds into using higher levels of math. Let's put it that way. Okay. Where is that denominator? Undefined. What can we not divide by in math? 0. Right, the denominator is undefined at 0. Hello. Vertical asymptote. X equals 0. Pretty much. All right, so wherever the denominator is undefined is your vertical asymptote. There was nothing there at the end, right? But if I put plus 0, that tells me it's a horizontal asymptote. Y equals 0. Thanks. Okay, so let me change my pen color. My horizontal asymptote is at 0. My vertical asymptote is at 0. Right? The question is, where does the rest of it go? No. I would like to. What? The book's better.
I have a book, I just haven't read it.
I guarantee it's better. I've read
I
it.
know, but it's a lot better. It's more detailed.
Okay, if I plug 1 in, what do I get for Y? Houston. Plug 1 in for X, what do I get for Y? Yep. Okay, if I plug -1 in, Kira. Thanks, Travis. That just tells me where to put my lines. You could pretty much always count on them looking like this. And I kind of missed my dots, but yeah, just make sure that they don't touch the asymptotes. Okay. That's it. So you're identifying the asymptotes, checking the orientation, and you're good to go. We're not getting really detailed on this one. No, I want to show you another one just to make sure you're good.
Way harder and way more complex and way more.
No, this is. Let's change this to. Okay, so look at this denominator. What number makes that 0? Okay, so there is a vertical asymptote at what? X equals -1. Because -1 plus 1 is 0.
Yeah, how does that make it 0? Or how does that make it 0? Vertically,
Can you divide by 0 in math? That's undefined. What does an undefined line have as a slope? What is the slope of a line? What is the slope of a line? I am totally botching this.
Is that a Y or a G?
What does a line look like with an undefined slope? Up.
Okay, well, I get that. That's what.
Okay, so all we're doing is looking at the denominator to see what number makes that 0.
I guess that means 1 number.
Okay, let's.
I just don't have, how do you know if it's vertical or horizontal?
If it's the denominator, it's vertical.
Well, okay, but so
It's the numerator.
then that's -4. You can add 4 and you have 0. So why couldn't it be horizontal?
Because the numerator has nothing to do with it right now. Why doesn't it make sense?
Because it's the same concept. If that's -4, you add 4 and you have 0. So I don't understand.
But that's division.
But he doesn't think he would be
-4 divided by 0 is 0. That's the slope of. That's undefined, right?
okay.
0. When you divide by 0, it's undefined,
Yes.
which is the slope of a vertical line. That's why it's a vertical line. Okay, there's my vertical asymptote. My horizontal asymptote deals with this number. Horizontal asymptote at y equals what? 1. It matches the number.
Oh my gosh.
So I have my brackets. Where do I orient this thing? Let's choose 0 and -2. The vertical asymptote's -1, so I want to choose 2 points on either side of it for x. What's 0 give us? -4. And -2 gives us 4. That's not what I wanted to do. The vertical asymptote's -1. You just want to use a point on either side of it. I mean, it could be -1 and 3 if you wanted, but those are just the easiest ones. So your graph's going to look like this. Just a general sketch. Okay, so does that make sense? Find the vertical horizontal asymptotes, orient it, and graph it. If it's a negative, you'll always be like this one. If it's a positive, it'll always be like this one. You notice the difference? Okay, last thing. Do you guys remember domain and range? The domain's the possible x values. What x values are possible? Okay, what else? And what? -1 is not possible. Okay, we're going to be here a while if we try to name them all. So can anybody come up with a general statement to describe the domain?
As it reaches to negative, infinity, y will reach.
No, that would be end behavior. All what kind of numbers? All real numbers except which one? Which one doesn't work? -1. Does anybody know what the range of this function is? All real numbers except 1. That's the horizontal asymptote, right? Was that so painful? For me, yes. Yeah, well, you just don't like math.
I need therapy. It's just not my strong suit, so.
I know, it's okay. Any questions that you need cleared up?
Can you go back to that real quick? Yeah.
Okay, that will be.
Screw up on the graph. Does that matter? 'Cause it doesn't. Like if you have to write.
Oh, I'm not looking for perfect. Just sketch it.
No, like because when you did it,
Yeah.
your point was down here. My point was up here. Because I just slightly screwed up.
I mean, don't be really far off, but
I mean, it's exactly the same graph.
yeah.
It's just I slightly messed up in the point. So
Okay, page 3 is your work.
all I did was flip these two numbers around.
1 through 6. So look at the directions. 1 through 4, you don't have to graph them. You're just identifying asymptotes, domain, and range. And 5 and 6, you're graphing. So it's pretty straightforward. You have about 10 minutes.